So all of the podcasts for section 4.6 are going to be based on all of the exponent laws that you know. Some of them that you just learned and some of them all the way back from grade 9. I want to take a look at all of the grade 9 ones first. These are all the ones that you should have known in the past. And all the podcasts after this are going to be looking at each one of these individually. So if you don't get them right off the bat, just go to the next podcast. You'll be fine. Case in point. Let's do the products of powers. Remember this one? If the bases are like, all you have to do is add the powers. Okay, so what would this be? This would be something like 3 to the power of 2 times 3 to the power of 5, which means just 3 to the power of 2 plus 5, which is 3 to the power of 7. That's that one. Quotient of powers, division. I always say to people that if you're going to do the division one, the thing that you have to think about is this line. That line actually is one big, huge subtraction sign. So how does this work? This would be like 3 to the power of 2 divided by 3 to the power of 5, or something like 3 to the power of 2 over 3 to the power of 5, which is, of course, there's the subtraction sign, 3 to the power of 2 minus 5, which is 3 to the power of negative 3, and then, of course, don't forget to flip it, change the sign. Power of a power. Let's look at that one. Now, let me clean this up a little bit here so that gives us a little bit more room. Okay. Power of a power. This is one you learned last year as well. But the easiest one with this one is if you've got a bracket, whenever you go across a bracket, always multiply. So this would be something like 3 to the power 2 to the power of 3. Going across a bracket, multiply it. This would be 3 to the power of 6. You got it. That's simple. Here comes our first mailman law. Remember the mailman law? Mailman meaning, of course, you distribute the mail to every household. So here's your neighborhood. There's the mailman. Just distribute. Go to here, go to here. So what does this mean? Well, what if you got 3x to the power of 2? That means this 2 goes to this guy and to this house. So this would be 3 to the 2, x to the 2, which of course 3 squared is 9. This would be 9x squared. See how it works? Real simple. Just distribute. Okay, so with that idea of distribution, check out the next one. The next one's going to be this one here. You've heard me say this a couple times on the last couple podcasts. Upstairs, downstairs, mailman. So this would be something like 3 over 5 to the power of 2. You take that 2, go upstairs and distribute the mail, and go downstairs and distribute the mail. So this would be 3 squared over 5 squared. 3 squared, of course, would be 9. 5 squared would be 25, and that's the evaluated form. And here's everybody's favorite, the 0 exponent 1. Yes, that's a to the 0 always equals to 1. But why does that equal to 1? Here's the thing that a lot of people don't teach you. Where did a to the 0 equal 1 come from? It comes from the quotient of powers. It comes from this one, right? What do I mean? What if you had 3 to the power of 5 divided by 3 to the power of 5? Wouldn't this be, according to the quotient of powers, 3 to the 5 minus 5, which would be 3 to the 0? Okay, but what does that actually mean? Well, watch. 3 to the 5 means 1, 2, 3, 4, 5 over 3 to the 5. 1, 2, 3, 4, 5. And then they all just cancel. When you cancel something out, 3 over 3 equals to 1. That's where the 0 exponent law comes from. Ta-da! Bet you didn't know that. Bet you didn't know that. And then a few more things that we talked about, of course. We had this new one, the negative exponent, which means, again, flip it, change the sign. Or if the negative's on the bottom, flip it back and change the sign. Okay, so you'd get something like, well, they use 3 here again. So 3 to the negative, I'm going to use negative 2. Why use 0.2? I don't know why they use 0.2. But anyways, this means flip it, change the sign, which would mean 1 over 3 squared, that'd be 1 over 9. Or if you had 1 over 3 to the negative 2, just flip it back. Flip it back means this is now 3 squared, which is now just plain old 9. You see how it works? Okay, so what I'm going to do is I'm going to take every single one of these guys, I'm going to go through them separately on the upcoming podcasts, and then I'm going to mesh this whole thing together to look at some really amazing, amazing problems. Stay tuned.